So now let's take a look at the equations of lines, but in a totally different way. So far we've been thinking about lines as we're given an initial value and then we track the pattern of is it increasing or decreasing at a constant change or constant addition or subtraction, and then let's see what that looks like. So we're given an initial and we're given the constant change, but sometimes we're not. So let's take a look at that, right? So it says, assume each of these scenarios is linear, make a table, and then come up with the equation. Let's do that. So we are given that the line has a slope of 2. Okay, well that's very abstract. I look at that and I see, okay, the constant change is, which is the same as the pattern, is plus 2, plus 2, plus 2, plus 2. So them saying the slope of 2 really means, okay, we have a pattern of plus 2, plus 2, plus 2, plus 2. And it goes through this point. Okay, well, that's abstract too. It really has a meaning, right? The explanatory variable, when it's 4, it has a response of 3. So when the explanatory variable is -4, then the responding variable was 3 in this particular scenario, whatever it's modeling. We're not sure. It doesn't have a context here. But, I mean, who knows? Maybe it's a temperature of maybe the explanatory variable is temperature, and who knows what's responding to temperature, pressures, rains, I don't know. I just said rains. So, but I still know that when the explanatory variable is -4, the responding variable is 3. And then I can start my pattern. Now I am used to finding the initial starting at 0 and then going 1, 2, 3. But this one starts at -4, so I'm going to start counting and keep counting. So -2, -1, until I hit 0, because then I know what my initial is. For instance, when it was 0 years since 2006, there were initially 22 hate crimes. So this is my goal, is to get this, because then I will know that whatever this is, the corresponding y value will be where it started and then proceeded with this pattern. I'll just put on a couple more just so that we can see this pattern. Okay, so it says that it's a constant change of plus 2, plus 2, plus 2. Well, I can do that. 3 plus 2 is 5, plus 2 is 7, plus 2 is 9, plus 2 is 11. I just found the initial, but I'm continuing this pattern because I can. Because why not? Okay, so we just found our initial value right there. And we know our constant change is 2. So that means our equation is then, what? So y is equal to the initial, 11, plus the constant change, 2, and then however many times that plus 2 got added. So, for instance, right, we really, when they started us at -4, we had been going backwards in the chart, interesting enough. So we went ahead and went forwards, but if we had given this initial value to get to -4, we would have been deducting, so that it would have had this pattern. And just to make sure that we're seeing this correctly, so if you start at 11 and you add 3 2 times, so add 3 2 times, that would be 6. 11, oopsie, silly me, the constant pattern is plus 2. Yep, I don't know why I saw 3 and 5 and said plus 3, but okay. So if we start at 11 and we add 2 2's, or we add 2 2 times, then we have 15. Okay, so this fits. This equation fits this. Start at 11, add 2 2 times, and then you're at 15. Now, interestingly, if you have an x of negative 4, this would read 11 plus 2 times negative 4. Well, 2 times negative 4 is actually negative 8. It's like we're taking away. So 11 take away 8 is 3. So this actually does fit this situation. And what happens, this negative 4, it's almost like it had us do the trend in reverse, which is fine. But voila, we have our equation. Now let's suppose that the line hits, okay, so now we have this initial point. Well, it's not the initial point, but it's a point on the line. So we have an explanatory variable value of 3 and a responding variable value of negative 2. And it has a slope of negative 2. So this is what the constant change is, that the pattern is minus 2, minus 2, minus 2, minus 2. Okay, so I'm going to start this with a table. And, I don't know, 3, negative 2. And if I went 3, 4, 5, then my pattern would be minus 2, minus 2, minus 2. So, negative 2, take away 2, negative 4, take away 2, negative 6, etc. Yeah, there's my pattern. But notice that this is not getting me back to the initial, because the initial, remember, is where the explanatory variable is 0. So if it was 0 years since 2006, then initially it was 22 hate crimes in that year. So similarly, we're still hunting for this 0. Okay, so then I think to myself, maybe I need a table that came before this. 3, 2, 1, 0. Then here I would have my initial value, whatever this is. Okay, so I'm thinking to myself, what number do I have to have here corresponding to 2, whereby if I subtract 2, I get negative 2? Well, that's 0. Excuse me, I haven't had my coffee yet. So 0 take away 2, negative 2. Okay, and then what number has to go corresponding with the 1 if the pattern says take away 2 and I get 0? So how much take away 2 is 0? 2. 2 take away 2 is 0. And I see the pattern now. Okay, so, and let's just see if that's true here. If we initially started at 4 and we had a constant pattern of minus 2, so 4 take away 2 is 2, take away 2 is 0, 0 take away 2, negative 2. Yes, that is its initial value. All right, so for the equation then, what do we have? We have y is equal to the initial, and then minus 2 is the constant change, so take away 2 however many times. So start at 4, and then to get to 3, take away 2 1, 2, 3 times. So start at 4, take away 2 3 times. Well, 4 take away 2 3 times would be 4 minus 6. And 4 minus 6 is negative 2. So yay! And then, let's do it again. Oh, oh boy. Now, we are not even given the pattern. We are not even given a constant change. So here, I'm thinking constant change. But we are given some values, so let's create a table. Now, this table is completely blank, which is nice, because I'm going to start it the way I normally would. And it's short, so I'm going to extend it. So I would normally go 0, 1, 2, 3, 4, 5, just because that's my nature. And I know that variables can be negative and even large, but this is always my gut routine. Start small, go big. Let's see, 3, 1, and 5, 2. Okay, so now, and I wrote a 1. There we go. And now let's think about this. So here's what I see. I see that this pattern, it has 2 hops. So it increments twice from 3 to 4, 4 to 5 in order for y to increase by 1. Okay, so, So increase of 1 over 2 increments. In the x value, well, that must mean that we're going up by a half. Add a half and you get 1.5, add a half and you get 2, right? So it's an increase of 1 over 2 increments. Okay, so I'm thinking here's our pattern. Yeah. So let's fill in this chart. If we found our pattern, then this would be 1.5. How much plus a half will give us 1 half? A half plus a half is 1. How much plus a half will give us a half? Well, 0. How much plus 1/2 would give us 0? Ooh, that's a negative half. Negative a half plus a half is 0. So we did this, we followed the pattern, and lo and behold, here is our initial value. Okay, so we use these 2 points and our traditional kind of grid here in order to figure out what our constant change is. Our constant change ended up being plus 0.5 every time. And we also backtrack to 0 in order to find our initials. So now we have both things that we need to write our equation. So it is initially a negative 1/2, and it is constantly increasing by a half however many times. Okay, so it starts at negative a half, and let's go up to 3, right? It increments, or it adds a half 3 times. So a half 3 times, that's 1.5. If you're down a half and you add 1.5, you're at 1. Yep, that one's good to go. Okay, so let's make a couple of remarks about what is happening here. First, to write the equation of a line, you have to have the initial value and the constant change. So and I'm going to write it like this. Where we have the initial, the constant change, and the number of times that constant change happens. to write an equation of a line in this format, you need the initial value and you need the constant change. Yeah? But the reality is, even if we're given 2 points, we can find those. We can find the initial value like we did here, and we can find the constant change. Okay, based on given 2 things of information. And I'm reminded that I've been told, like, if you have 2 points, you can find the equation of a line. 2 points regardless of where they are, which is absolutely true, because from these 2 points we can find the constant change, and from the constant change we can find the initial. So, and a lot of people have probably been trained, and maybe I'll write this down too after I write this remark, that, okay, so to solve this equation for the missing amount, I'll show you that, but I don't expect you to go back to that. Okay, so sometimes another remarkable thing is that sometimes we use 2 points to find the constant change, and then use the constant change to find the initial. Yeah, so just like in this example here, if they give us a constant change, yay! But if they don't, you have to use those 2 points to find the constant change, and then use that constant change to find the initial value. Now, I know that some teachers and some of my students of the past have said, okay, well, if you're given 2 points, you can find the slope, because there is a formula for the slope. What is it? The change in the y values, so it changed up by 1, and the change in the x values, well, it went up by 2, so notice our slope is a half. And then they're like, well, if I need to find that initial value, they do this thing, so maybe I'll put this in a bubble somewhere. Okay, off to the side. So they do this thing where they're like, well, we know it's linear because we were told. So it's a valid assumption that we can write this as y equals initial plus a constant change x times. And we just found out that the slope is a half. So, and we know a coordinate pair. So then they say, okay, well, let's use this. Plug in the y value, okay, 1. We don't know the initial, so that's b. We do know the constant change, or the slope, that's a half. And the x value that corresponds to 1 was 3. And then they go ahead and solve this. And this will totally work. So just so that we finish this thought, 3 halves is 1 1/2. And you're going to need a negative half here to add to 1 1/2 in order to get to 1. Because 1 1/2 is a little bit more. So, oopsie, negative. Yeah, so it did actually find us the initial value. But the reality is, I want you to see that it's true that this works, but really all of this was generated by finding that constant change and then using that constant change, which you did here, really, to find the initial value. Okay, so regardless of whether you use this table of values to find the initial value or you use the linear equation, I mean, that's up to you. But in general, we are going to need this initial value in order to write our equation of the line. And we're going to need this constant pattern, this plus a half, plus a half, plus a half business. Okay, and that's the slope. So let's detect if things are linear or not. Do the following values create a line? Show how you know. So I want you to notice that this is not our traditional 0, 1, 2, 3, 4, 5 business. But let's just see if this has a pattern in the y values. So $35 plus 12 makes 47. 47 plus 12 makes 59. 59 plus 12 makes 71. So maybe, yes, my initial gut reaction would be like, probably yes. Yes, this is linear. But notice that these x's are not 0, 1, 2, 3. They're not incrementing at the same increase of 1 or what that we're used to. So I'm going to go ahead and build another table of values. I'm going to start it at 3 instead of starting it at 0, even though that's against my, I don't know, intuition. But I'm going to start at 3, but I'm going to increment, I'm going to do count by ones like we're used to. So 3, 4, 5, 6, 7, 8, 9, 10. And I'm just doing that because I noticed that there are gaps here that they didn't put in. So they have a value of 35 corresponding to 3, a value of 47 corresponding to 5, a value of 59 corresponding to 8, and a value of 71 corresponding to 10. I already see that there's going to be a problem because from 3 to 5, so it increments by 12 over 2 times. Let's actually write that down. Okay, so add 12 over 2 increments. I'm on it. Oopsie. No. That would be way too much, right? If we increment by 12 over 2 jumps, oh, so these should really be plus 6 would be our pattern. Plus 6 would increment by 12 over 2, or increase by 12 over 2 increments. Okay, so plus 6 is our pattern. Let's fill in this table. 35 plus 6 is 41. 41 plus 6 is 47. 47 plus 6, 53. 53 plus 6 is 59. 59 plus 6 is not 59. So there's a problem there. And I want you to notice that right here, that problem shows up where here it increments by 2, but then here it incremented by 3. So they accidentally skipped an entire one of these patterns, right? In order to, so no, not linear. There's a mistake in it. Well, I mean, a non-linear piece of it. Okay, now let's check this one. So let's do the same analysis here. From 25 to 13, that is a decrease by 12. From 13 to 1, that is a decrease by 12. From 1 to negative 11, that is a decrease by 12. Okay, and let's see. So I'm going to set up a new table of values. Starting at negative 4. Okay, starting at negative 4, and I went up by 1, counted by 1s all the way up to 5, just to see what happens here. Right, negative 4 corresponds to 25, negative 1 corresponds to 13, 2 corresponds to 1, and 5 corresponds to negative 11. And now our job is to fill in these gaps. Well, decreases by 12 over, okay, how many times does this happen? 1, 2, 3. Over 3 increments. Okay, well, that means I think 4. Decrease by 4 every time, because there are 4 sets of 3, or however you want to say it, 3 sets of 4 in 12. So decrease by 4. Let's see if that works out. 25 take away 4 is 21. 21 take away 4 is 17. 17 take away 4 is 13. So far, so good. 13 take away 4 is 9. 9 take away 4 is 5. 5 take away 4 is 1. So far, so good. 1 take away 4 is negative 3. Negative 3 take away 4 is negative 7. Negative 7 take away 4 is negative 11. This one worked. This one is linear based on the information we're given. We're only given a little bit of information, so we don't have the whole picture, but still, based on the information we're given, we could say likely to be linear. Yes, based on this data. Okay, so quick summary. If we're going to write an equation for a linear function that does not supply us with the initial value or the constant change, then we are going to have to find the constant change and then use that constant change to find the initial value so that we can write our equation, because we need the initial and we need that constant change. Okay, so those two things are needed, but we can usually find those from the information given. And then we can translate between a line's graph, an equation, a table, and a scenario. And that makes lines very applicable.